Hello. We're going to go over some characteristics of polynomials so that we can get ready to do some graphing. So we need to talk about what the equation tells us about the graph. For example, f of x equals x cubed plus 3x squared minus 13x minus 15. What can we tell about our graph just from the equation? We already know one thing. The degree is 3, so when we solve it, we should get 3 solutions or 3 zeros. Now we have to be careful about calling them zeros because they may not be actually real numbers like we've seen before. So the maximum number of zeros is 3. The other thing it tells us is the maximum number of turns the graph will have. Like a parabola has 1 turn. It turns out the number of turns is always 1 more or 1 less than the degree. So the number of turns in an n-degree equation is n minus 1. So I've got this chart here. Degree 2, so a parabola, is going to have at most 2 turns, or 1 turn. A degree 3 is going to have at most 2 turns. And you can see a degree 4 looks kind of like a W here, or maybe an M shape. The number of turns is always n minus 1. Another thing we can tell is something called end behavior. End behavior has to do with what the left side is doing or where it's at compared to the right side. So in this little sketch of a parabola, this parabola on the left side is low, it's negative, and over here on the right side, it's also negative. This cubic equation here is positive on the left side, but it's negative on the right side. It turns out there's a pattern to these end behaviors. The even patterns, 2, 4, and 6, have similar end behaviors, as do the odd powers. The odd degrees have similar end behaviors. If we look, our odd degrees start and end in an opposite way. So if the left side's negative, like here, then the right side's positive. Over here on our 5th degree equation, this one has a left side that's positive, but a right side that's negative. Our even degrees start and end in a similar fashion. So in my parabola here, I have a left side that's negative. I will have a right side that's also negative. In my 4th degree equation here, this W shape or the M shape, I'm going to have a left side positive. I'll have a right side positive. So those are some things that can help us out when we do some graphing. So let's look at this equation that I started with. We know it's a cubic equation, so it has a maximum number of 3 zeros. It's got a maximum number of 2 turns. And because it's odd, it's going to start in an opposite fashion than it ends. If the left side's negative, the right side's positive. Or if the right side's positive, the left side's positive, the right side's negative. And the A value, our leading coefficient, is positive. So it's going to resemble our plain old x cubed graph. So it's going to look kind of like this one here. The left side's going to be negative, and then the right side's going to be positive. So to summarize, our degree tells us the maximum number of zeros, the maximum number of turning points, and it also gives us some information about the end behavior along with that leading coefficient or A value. So here's a quick example. What's the maximum number of zeros? Well, since the degree is 3, there will be a maximum number of 3 zeros. How about the maximum number of turning points? Again, the degree is 3, so there are a maximum number of 3 minus 1, or 2, turning points. And how about that in behavior? Well, it's an odd degree, so it's either going to be left negative to right positive, or it's going to be left positive to right negative. So here's where we look at our leading coefficient. Our A value is negative, which means it's opposite of just the plain old x cubed graph. And the plain old x cubed graph starts negative. Well, the negative in front of our x cubed here means we're going to flip it across the x-axis. So our graph is going to start on the left side positive and end down here on the right side negative.